Something from our solar system is cruising through our cosmic neighborhood right now, and the latest data from the James Webb Space Telescope has scientists scratching their heads in confusion. Here's the thing, 3I Atlas isn't playing by the rules we expected, and what we're discovering is raising more questions than answers. Stick around, because this interstellar visitor might just be the strangest thing we've seen yet. The unexpected discovery. When astronomers first spotted 3I Atlas on the 1st of July, 2025, using the Atlas Survey Telescope in Chile, they knew immediately that something unusual was happening. This wasn't just another chunk of space rock making its rounds through our solar system. The trajectory told a different story entirely. This object was traveling on a hyperbolic path, meaning it came from somewhere far our sun's gravitational influence. What makes this discovery so remarkable is how bright it appeared from such an incredible distance. When scientists first observed it, 3I Atlas was sitting at about 4.5 times the distance between Earth and the Sun. At that range, most comets would be barely visible specks, yet this object was shining brilliantly in the darkness of space. This brightness suggested something truly massive, potentially around 20 kilometers in diameter if we're talking about a typical asteroid. The timing couldn't have been more perfect for science. Unlike the first interstellar visitor, 1I Oumuamua, which zipped through our solar system in just 2 months back in 2017, we caught 3I Atlas early enough to actually study it properly. Scientists immediately mobilized every available telescope to catch this cosmic wanderer. The excitement in the scientific community was palpable, but as more telescopes pointed at this mysterious visitor, the data started painting a picture that didn't quite match what anyone expected. The Webb observations. When the James Webb Space Telescope turned its powerful infrared eye toward 3I Atlas on the 6th of August, 2025, astronomers were hoping for clear answers about this interstellar traveler. Instead, they got something that made them pause and look twice. The near-infrared spectrograph aboard Webb began capturing data that would fundamentally challenge our understanding of what interstellar comets should look like. The first thing that jumped out from Webb's observations was the chemical composition of the gas surrounding 3I Atlas. The telescope detected a massive cloud of carbon dioxide enveloping the comet, and when scientists calculated the numbers, they found something stunning. This object was losing about 70 kilograms of CO2 every single second. That's roughly the weight of an adult human being vaporizing into space every tick of the clock. Here's what makes this finding so peculiar. When Webb looked for water vapor, which is typically the dominant gas in comet atmospheres, it found surprisingly little. The upper limit for water loss was only about 4.5 kilograms per second. This means 3I Atlas has a carbon dioxide to water ratio that's completely off the charts compared to what we normally see in solar system comets. The data quality from Webb was exceptional, providing the clearest chemical fingerprint of an interstellar object we've ever obtained. The carbon dioxide mystery. Let's dive deeper into this carbon dioxide puzzle, because it's genuinely weird when you understand what it means. In our solar system, comets typically form in 2 main regions, the Kuiper belt Neptune, and the even more distant Oort cloud. Both of these regions produce comets that are dominated by water ice. Carbon dioxide is usually a minor component, accounting for maybe a few % of the gas at most. The fact that 3I Atlas is absolutely loaded with carbon dioxide tells us it probably didn't form in a region similar to our solar system's comet factories. Instead, it might have originated in an ultra-cold environment where carbon dioxide could freeze solid alongside water. We're talking about temperatures that would make the coldest regions of our solar system look positively balmy by comparison. What's really intriguing is what this tells us about the diversity of planetary systems across the galaxy. If 3I Atlas formed around another star, then that star system must have very different characteristics than ours. Some researchers have pointed out that this unusual composition could make 3I Atlas somewhat rare even among interstellar objects, or it suggests these CO2-rich comets might be more common than we thought. Size and acceleration questions. Now here's where things get really head-scratching. Scientists have been struggling to pin down exactly how big 3I Atlas actually is, and the numbers don't want to cooperate with each other. Remember how I mentioned it appeared unusually bright when first discovered? That brightness suggested a large object, possibly 20 kilometers across. But as more data rolled in, that estimate started looking questionable. The problem is that brightness in astronomy can be deceiving. One of the most peculiar findings came when scientists analyzed the comet's movement. Most active comets experience what's called non-gravitational acceleration. Basically, the jets of gas shooting off the surface act like tiny rocket engines, slightly altering the comet's path. But observers tracking 3I Atlas noticed something strange. They couldn't detect any significant non-gravitational acceleration despite all that gas being released. This lack of rocket-like push suggests that 3I Atlas must be substantially more massive than the amount of gas being released. When you do the math, accounting for the 70 kilograms per second of carbon dioxide streaming off the surface, you end up with an estimate that the solid nucleus must be at least 5 kilometers in diameter, possibly much larger. If 3I Atlas really is 5 kilometers or larger, it's a completely different beast compared to previous interstellar visitors. The nickel anomaly. Just when you thought 3I Atlas couldn't get any weirder, astronomers detected something in its gas cloud that made them do a double-take, an unusual abundance of nickel. Not just a little bit of nickel, but amounts that were surprisingly high compared to iron, which is typically more abundant in cosmic objects. This ratio flipped the script on what scientists expected to find. In most asteroids and comets from our solar system, iron vastly outnumbers nickel. But in 3I Atlas's coma, that cloud of gas and dust surrounding the nucleus, the nickel-to-iron ratio was unusually high. Now, before anyone jumps to conclusions, finding unusual metal ratios doesn't automatically mean anything artificial is going on. Space is full of chemical surprises, and different formation environments can produce wildly different elemental abundances. One possibility is that 3I Atlas contains material from a specific type of stellar explosion or cosmic event that concentrated nickel. The presence of these unusual metals also helps scientists understand the object's origins. The specific mix of elements can serve as a fingerprint of sorts, potentially pointing back to the type of star system where 3I Atlas was born.